Hey everyone, so today we're going to be focusing on factoring binomials that have a difference of perfect squares. So in the PowerPoint, I reviewed what a perfect square is. It is the product of a number times itself. So like 4 times 4 is 16. 16 is a perfect square. X squared times x squared is x to the fourth. X to the fourth is a perfect square. So in order to factor what binomials we're going to be looking at today, we need to have two perfect squares, and there needs to be a subtraction sign in the middle. That's why it's called the difference of perfect squares. Difference in math, we know, means subtraction. So we're going to break it up into two different binomials, and the first thing we want to do is find the square root of our first term. So we want to find the square root of 9x squared. If you want, you can break this into two pieces, the square root of 9 and the square root of x squared. That's fine. The square root of 9 is 3, because 3 times 3 is 9. And the square root of x squared is just x, because x times x is x squared. Now, the second thing we need to do is find the square root of the second term, which is 64. Leave out the subtraction sign for now. The square root of 64 is 8, because 8 times 8 is 64. So for these two, we can actually put those together. That's going to give us 3x. Now we have our 3x and we have our 8. So we're going to take both of those terms and we're going to put them in our parentheses. So I'm going to make two sets of parentheses. Our 3x is going to go first in both sets. Our 8 is going to go second in both sets. And then one gets a plus, one gets a minus. Does not matter which one gets a plus, which one gets a minus. Multiplication is commutative, so those things can move around. And that's our answer. A good way to check is to distribute this out or do the box method. You should end up with what you started with. So let's do that real quick. And I'm going to do the box method for this one. So I'm going to set this up. We'll put 3x plus 8 on this side, 3x minus 8 on this side. 3x times 3x gives us 9x squared. Remember to add those exponents of same bases. 3x times negative 8 gives us a negative 24x. 8 times 3x gives us 24x over here. And then 8 times negative 8 gives us negative 64. Now we always check for like terms. We see that these are like terms and they're actually additive inverses. So they're the same terms but with different signs. So that means these are going to just cancel out. So all we're left with is 9x squared minus 64, which is what we started with. That's why we need to have a plus and a minus, because these are going to have to cancel out in the end. All right, I'm going to do the second example from this PowerPoint with you guys also. Let me just move over here. Zoom in a little. Okay, so in this case, our variable is in the second term, which is fine. Still going to do the same exact process. So I'm going to find the square root of 16. The square root of 16 is 4, because 4 times 4 is 16. And then I'm going to find the square root of 25y squared. If you want, you can break them up. In this case, I'm not going to, because you see where they came from the first time around. So the square root of 25 is 5, and the square root of y squared is y. Now we're going to take these two terms, move this down a little to the side, and we're going to put them in our parentheses. We have two sets. Our 4 is going to go first in both sets of parentheses, and our 5y is going to go second. And we have our plus and minus. And that's it. That's our answer. That's how you factor the difference of perfect squares. I'm going to check it real quick just to make sure that that's what we started with. I'm going to do that over here. Actually, I'll do the distributive method this time, just so we can see both methods. So I'm going to take the 4 and distribute that twice. 4 times 4 is 16. 4 times 5y is a negative 20y. Then I'm going to distribute this positive 5y twice. 5y times 4 gives us a positive 20y. And then 5y times negative 5y gives us a negative 25y squared. Just like we saw with the box method, we have like terms here. This negative 20y and this positive 20y, when we add those together, they're going to cancel out. They're additive inverses. So we're just left with 16 minus 25y, which is exactly what we started with. So we know that this is a factored version of this.